Sir Isaac Newton, his life and his scientific contributions. Sir Isaac Newton's work laid the bedrock for our modern understanding of the natural world and changed the course of scientific inquiry. Join me on this journey where we can explore the life, achievements, and enduring impact of Newton. Newton's journey began in the quiet village of Woolsthorpe in Lincolnshire, England. He was born on Christmas Day in 1642, based on the Julian calendar, the same year that the Italian scientist Galileo, the father of modern science, passed away. Newton's father, also called Isaac Newton, died 3 months before the birth of his son. His mother, Hannah Iskoff, raised the prematurely born weak child till the age of 3, when she married Barnabas Smith, a wealthy man. Newton was left in the care of his grandparents for the next 8 years. Upon Barnabas Smith's passing, Hannah returned to Woolsthorpe with her 3 children from the second marriage and was reunited with Newton. Woolsthorpe Manor is a historic site located in Woolsthorpe by Colsterworth, a village in Lincolnshire, England. It is most famous for being the birthplace and childhood home of Newton. Newton's grandfather bought the manor in 1623. In 1653, just about the time when Hannah moved back to Woolsthorpe, the manor was rebuilt. After Newton's death in 1727, the house went to one of his relatives, a gambler, who sold the property. Eventually, Edmund Turner, a fellow of the Royal Society, bought the property. He was responsible for some significant renovations at Woolsthorpe Manor in the 18th century. He made efforts to preserve the historical significance of the property, recognizing its importance as the birthplace of Isaac Newton. Woolsthorpe Manor underwent further restoration efforts in the 20th century and is now managed by the National Trust. The manor stands as a testament to the early years of Newton and his groundbreaking contributions to science. It provides insight into the environment in which one of history's greatest scientists grew up and conducted his early experiments and observations. The famous apple tree, a variety called the flower of Kent, still stands there. The original apple tree from 400 years ago partially fell down sometime in the 1800s, but it rerooted itself and still gives apples. Descendants of the tree can be found in Trinity College as well as at the Isaac Newton Mathematical Institute, both in Cambridge. As a young child, Newton went to local elementary schools. When he was 12, Newton was enrolled at the King's School in Grantham, about 7 miles away from Woolsthorpe. Instead of commuting the 7 miles every day, he lived in the house of Mr. Clark, who was an apothecary. This helped Newton to develop his interest in chemistry. During those times, the Grantham Grammar School curriculum focused predominantly on the study of Latin and the Bible, with a bit of basic mathematics. Newton was an excellent craftsman from his childhood, and he built wooden dolls' furniture for Mr. Clark's daughter, a model of a working windmill, clocks, and other mechanical devices. Despite initial academic struggles, Newton quickly rose to the top of his class. He even stood up to bullies who attempted to harass him. After 4 years at the grammar school, Newton's mother brought him back to Woolsthorpe, intending to prepare him for a farming life. Instead of tending the sheep or the horses, Newton spent his time studying sitting in the orchard. Understanding Newton's potential, The grammar school principal, Mr. Stokes, and Newton's uncle encouraged Hannah to send her son back to Grantham to continue his studies. In 1661, Newton started as an undergraduate at Trinity College in Cambridge. Even though his mother had the means to support him in college, she only gave him a small allowance. Newton supported himself by doing chores and running errands for the tutors and wealthier students. At the end of 3 years of his study, he received a university scholarship, which meant that he had more time for his studies. In the 17th century, Cambridge University and other universities followed the teachings of Aristotle, which were based on the geocentric model of the universe. During this time, the famous astronomers Copernicus and Kepler came up with the heliocentric model of the universe. In addition to being influenced by the teachings of these astronomers, Newton was influenced by the motion studies done by Galileo, the works of the French mathematician René Descartes, and the experimentation techniques set out by the Irish scientist Robert Boyle. Thus, rather than focusing on the university's curriculum of that time period, Newton self-studied various topics, including mathematics, astronomy, light, and history, to name a few. In 1665, Newton received his bachelor's degree from Cambridge University. When plague hit Europe from 1665 to 1666, the university closed to prevent contamination amongst its students. Newton moved back to his family home from Cambridge and lived there till 1667. During this remarkable period, Newton unveiled a series of his celebrated breakthroughs, fittingly referred to as his Annus Mirabilis. The story about how an apple fell on Newton's head as he was sitting under the tree is quite famous. It is unclear if this was true, though in his old age Newton had narrated this story to others. Newton realized that the force that was pulling the apple towards the earth was the same force that was keeping the moon in earth orbit. Or in other words, the force of gravity is universal. Based on this, later in 1687, Newton published his law of universal gravitation, which states that every mass pulls on every other mass with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. The inverse square law finds relevance in numerous scientific domains, including but not limited to light, radioactivity, and electricity. While observing a falling apple, Newton noticed that its speed accelerated with each passing second. This observation led to Newton's groundbreaking creation of a new mathematical discipline known as calculus. He employed calculus to demonstrate the elliptical trajectories of celestial bodies orbiting the sun. Since then, calculus has proven instrumental in addressing dynamic problems across various fields of science and engineering that evolve with time. Notably, Gottfried Wilhelm Leibniz, a German mathematician, also independently developed calculus. In this period, Newton also engaged in experiments involving light. He created an aperture in his window covering and allowed sunlight to pass through two prisms. The initial prism separated the white light into its constituent colors, a concept now familiar to us. Subsequently, the second prism recombined these colors, demonstrating that white light comprises a blend of various colors of light. In 1668, Newton was elected as a Fellow of Trinity College, and the same year Newton invented the reflecting telescope. This was the first time an astronomer had built a telescope with mirrors instead of lenses. In 1669, Newton became the second Lucasian Professor of Mathematics at Cambridge, the most prestigious mathematics position, and he was only 26 years old. The first Lucasian professor was Isaac Barrow, who was Newton's teacher at Trinity, and the only person to whom Newton shared his research findings. Understanding Newton's extraordinary mathematical capabilities, Barrow recommended Newton to the position of Lucasian professorship. Newton's job at Trinity required him to prepare notes, deliver lectures to students, and file the notes with the library. His classes were not well attended, and oftentimes he lectured in empty lecture halls because the students did not understand him. In 1671, Newton's reflecting telescope made its debut at the Royal Society in London, and shortly thereafter, at the age of 29, he was granted membership as a Fellow of the Royal Society. During this period, he also released his discoveries on optics and the reflecting telescope. However, Robert Hooke, a renowned scientist and the curator of experiments at the Royal Society, raised criticisms against Newton's work, which resulted in Newton's self-isolation from the scientific community for quite some time. In 1684, Newton sent a short paper on his findings on motion to Edmund Halley, an astronomer and member of the Royal Society. Halley encouraged Newton to write about his findings about gravity. So, 20 years after discovering his ideas about gravity, Newton wrote his famous masterpiece, The Three Parts of the Principia, or the mathematical principles of natural philosophy, which covered the three laws of motion as well as the law of universal gravitation. Funded by Halley, the Principia was published in 1687 by the Royal Society. Newton's laws of motion are fundamental principles in physics. First law, or the law of inertia, states that objects remain at rest or in uniform motion unless acted upon by an external force. Or in other words, inertia is the tendency to maintain current states of rest or motion. The second law, or the law of acceleration, states that a force applied to an object causes it to accelerate, which is directly proportional to the force and inversely proportional to its mass. The third law, or the law of action and reaction, states that for every action there is an equal and opposite reaction. These laws underpin classical mechanics, explaining how objects move and interact with forces. Situated at Trinity College, the esteemed Wren Library is home to an original edition of Newton's Principia with his annotations. This library also houses Newton's personal belongings, handwritten manuscripts, and his extensive correspondence, all serving as tangible echoes of the enduring legacy left by this iconic scientist. During his time at Cambridge, Newton developed an interest in alchemy. His interest in alchemy was primarily a product of the time in which he lived. Newton believed that by understanding the secrets of nature through alchemy, he could gain insights into the natural world and its underlying principles. It is essential to note that Newton's contributions to science far outweigh his involvement in alchemy. While his interest in alchemy is a historical curiosity, it should not overshadow his more significant and enduring scientific achievements. In 1696, Newton was appointed as the Warden of the Royal Mint, and he held this position till 1699. From 1699 till his death in 1727, Newton served as the Master of the Royal Mint. During his tenure, he implemented various reforms to combat counterfeiting and improve the quality and consistency of the coinage produced by the Royal Mint. In 1703, Newton became the President of the Royal Society. And a year later, Newton published his book Optics, which explained his work about the science of light and colors. On April 16, 1705, Queen Anne knighted Newton in recognition of his outstanding contributions to science and mathematics. This honor was bestowed upon him at Trinity College in Cambridge. It was the first time a scientist was knighted, and Newton became Sir Isaac Newton. Newton died on March 20, 1727, according to the Julian calendar. He was buried with great honor at Westminster Abbey. Newton was interred in a prominent location within the Abbey known as the Scientist's Corner or Scientist's Aisle, where several other renowned scientists and scholars are also buried or commemorated. Newton's tomb is located in the nave of Westminster Abbey, not far from the entrance. The monument and tomb of Sir Isaac Newton in the Abbey are rich in symbolism and details that reflect his contributions to science and mathematics. The central focus of the monument is a reclining figure of Newton himself. He is depicted in a contemplative pose with his head resting on his left hand. He holds a drawing compass in his right hand, which symbolizes his contributions to geometry and mathematics. Around the base of the monument, several scientific instruments that highlight Newton's work are depicted. These instruments include a pair of dividers, a reflecting telescope, and a celestial globe. Also at the base, an open book rests at Newton's feet. The book represents his contributions to the advancement of knowledge. Above Newton, there is a coat of arms which shows symbols associated with his family. One of the Latin inscriptions on the tomb can be translated to, "He surpassed all of humankind in genius." At the top of the monument, there is a winged skull, which was a common motif in 18th century funerary art that symbolized mortality and the passage of time. Alexander Pope, an 18th century English poet, paid tribute to Newton in his poem Epitaph, intended for Sir Isaac Newton. Nature and nature's laws lay hidden night. God said, "Let Newton be," and all was light. The monument to Sir Isaac Newton in Westminster Abbey is a tribute to his enduring legacy as one of the greatest scientists of all time. Here are a couple of Newton's famous quotes. Start quote: "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself in now and then, finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." End quote. Start quote: "If I have seen further, it is by standing on the shoulders of giants." End quote. These quotes reflect Newton's humility, his recognition that there is always more to discover in the pursuit of knowledge, and acknowledgement of the contributions of those who came before him. Sir Isaac Newton's life and contributions stand as an enduring testament to human ingenuity and scientific brilliance. His laws of motion and theory of universal gravitation revolutionized science and remain foundational to our understanding of the physical world. Newton's legacy continues to inspire generations of scientists and thinkers. Thank you.